kind of dive in here. I guess before we get going, we had talked about polynomials last time, just kind of identifying and naming polynomials. Did anybody have any questions on those 1 through 4? I wouldn't suspect so. I mean, it's pretty straightforward. Basically, you're just using a definition. There's no calculation even to speak of, but, you know, I can ask, doesn't hurt, right? Okay. So today, then, we're going to move on and start talking about section 2, which is titled Correlation. So remember what we've been talking about here the last couple of days. We talked about polynomials in the first section. And what we're going to be talking about the remainder of the chapter is really about this idea of modeling, which what that means is we're basically going to find a mathematical rule to describe some real life behavior. And there's a couple of ways that somebody could go about doing or creating a model. The method that we're going to be talking about in this case is called regression. So when we make a mathematical model using regression, we're going to take some data, and with that data, we're going to create a mathematical rule that best fits that data. So in this chapter, we're going to talk about a couple of different types of regression. So we're going to talk about linear regression, quadratic regression, exponential regression, logistic or logarithmic, I can't remember for sure, but we'll see that when we get there. And then power. So one thing that we're going to be particularly interested in when we build out these regression equations, those are going to represent best fit equations, but how good is the fit, right? So for a linear situation, we're going to measure that fit with something called the correlation coefficient. that we abbreviate with the letter R, the lowercase letter r. And for these others, we're going to use something called r squared. So when we talk about correlation, I want to be really clear about what we mean in a mathematical sense. Stupid pen. So correlation is not the same as causation. So in a mathematical sense, correlation just means that the two variables that you're kind of studying have a linear relationship between them. That's all we're saying, that there's like a mathematical relationship between these two variables in your data set. Causation would imply that one variable causes the change in the other. That's much stronger than correlation, right? If one variable causes a change in the other, will those variables correlate? Probably. But just because the variables correlate doesn't mean that one is causing the other. So for example, we could measure, like we have this stapler here on my desk, right? And we could say, okay, well, we could measure every day that goes by and the number of tiger sightings we see after that many days. Now, it's going to strongly correlate that this stapler appears to repel tigers because nobody's seen a tiger anytime the stapler's been around, right? But is the stapler causing tigers to be repelled? Certainly not. That's ridiculous, right? It has, well, the tiger sightings, the lack of tiger sightings are purely a geographic instance. There's no tigers native to Michigan outside of a zoo. Clearly, this isn't a zoo. Like, we're not going to see any tigers, unless you wandered onto Joe Exotic's property or something here, right? And certainly, if you take the stapler with you and jump in the tiger pit at the zoo, that stapler ain't helping you. Everybody agree? Although from a data standpoint, if you weren't really being careful, you might want to argue that. And that's an example of like bad statistics, like bad data sense. Everybody cool as to like correlation versus causation? This is just more has to do with like you interpreting things in the real world when somebody says that blah, 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 blah. It's like, well, okay, those variables seem to line, like, is it really reasonable that this would be causing this? Okay. So what we want to talk about here is this correlation coefficient. And we're just going to talk about some basic kind of facts here. So the values for this correlation coefficient are all between -1 and +1. So if we kind of draw out our number line here, where -1 is here, +1 is here, and like 0's in the middle. So as we get closer to -1 or +1, we say the correlation is getting stronger. And as we get close to 0, we'd say that correlation is weaker. Now, When we have a negative correlation like this, we'd say that's like a strong negative correlation. And down here at the positive side, we'd say that's like a strong positive correlation. Maybe let's just do it like this. That probably makes more sense to write it that way. Everybody feel okay with that idea? So remember that this correlation coefficient is used only to measure linear models. So when we say that something has a negative correlation or positive correlation, what we're really saying is that that linear model would have negative slope or positive slope. Okay? And when we say the strong correlation means it looks a lot like a line, and weak correlation would mean it doesn't look very much like a line at all. Everybody's okay with that? If you actually get a correlation value at 1 or -1, it means that there's actually a line that exists that all the points in your data set fit onto. Like you can actually build a line that has all the points in your data set as points on the line. And you can't really get a correlation value of 0. That's kind of a theoretical value, because you need like a random, like a perfectly random distribution of points, which is like not something that really happens. It's kind of a theoretical value. Everybody feel okay about what these value of R kind of means? So let's look at a couple of pictures here. If we're just looking to like estimate a correlation by hand or just with our eyes, like not actually calculating this, we're just going to kind of do an estimate. The best way to look at that is with something called a scatter plot, which is just basically plotting the points in your data set. So if I take a look here at this scatter plot, you know, the data looks pretty linear, right? It's like, if you want to draw a best fit line in there, that's probably a reasonable estimate of a best fit line. The data's pretty close to the line. Looks reasonably linear, right? So if we do the same thing, we look at a different scatter plot here. So if I take a look at this one, this correlation is much weaker. Again, if I try to draw a best fit line through there, maybe it looks something like that. And here you can see that on average, the points are much further away from our best fit line than they were in the other graph. Is everybody okay with that? So for a strong correlation, probably we would, if I asked you to estimate this, if you said somewhere between like 0.7 to like 1, but not including 1, I would say that's a reasonable estimate just by using your eyes. When we talk about strong correlation, that's the kind of value that we're probably talking about. For a weak correlation, here notice that the slope is negative. So maybe this would be like negative 0.7 is less than R, which would be less than 0 or something, somewhere around. Actually, I would probably say up from that, probably like 0.4 or something. 0.4 is pretty bad. This still, like, you can see that there is some linear shape to it. It's a pretty thick looking band of points that's kind of going in that line shape. So it's not like total nonsense. But I think that those would be reasonable estimates if we ask for an estimate. Does that feel okay? We haven't done anything yet. We've just kind of done some definitions. And in general, when we do these regressions and we talk about this correlation, the calculator is going to do all of the work for us, which is pretty cool. Because if you notice, we haven't talked at all how to construct one of these best fit lines or how to get an absolute best fit. or how to build one of these regression equations or calculate this correlation coefficient. Because really, in this chapter, the calculator is going to do all that work for us. There's a couple of different ways that these correlation coefficients could be built, but in this class, we're not going to talk about those different methods or how to actually do this by hand. If you went ahead and took a statistics class at a later point, that kind of stuff would be discussed. Or a class that has a greater emphasis on statistics, that kind of thing would be discussed. But for us, we're just going to kind of let the calculator do what it's doing. Okay. So what we have here is a data set, and we're going to build a linear model for this data set and calculate the correlation coefficient to look at how good this model is. Okay with that? Okay. So first thing I'm going to do is, this is all going to be on our calculator. So if you want to take your calculator out and follow along, that's great. If you're like, yo, I'll just, watch with my eyes and that's better for me, that's cool too. Or if you want to go back and rewatch what we're about to do, you can always do that on the recording later. Okay, so this process is going to have several steps because we're actually going to want to do something with this model at the end also. So the first thing we're going to do is we're going to enter the data into our calculator because the calculator needs this data to create the model or anything else with it. Okay with that? So to enter the data into our calculator, we're going to start by pressing the stat button, which is there right next to the left arrow. From the stat button opens up the stat menu. We're in the edit tab. Under the edit tab, we're going to select the edit command. In the edit command, you're going to see a bunch of lists, L1, L2, L3, etc. Probably most of us, these lists are blank already. If that's the case, you can go ahead and start typing in the values in the table just into L1 and L2. If you do have stuff in your list, there's two things that you can do. You can delete the entries individually by pressing the delete key. So if this 10 is wrong and I just typed it in twice and I didn't mean to, I can press delete and it'll just get rid of it. Or if I want to get rid of everything in a column, I can move my arrows up into the title. See how my cursor is now on the L1. Press the clear button and then the down arrow and it'll wipe the entire column for me. One thing you want to make sure you do not do is when you're up there on the L1 is press delete, because it's actually going to remove the entire list along with the list label, and it's kind of a hassle to fix that. It's certainly, I can help you fix it if you do that. It's not that big of a deal, but don't do it, just easier if you don't. All right, so I'll clear out these guys and then I'm going to type my stuff in. Just by the way, the data here represents the price of a can of soda pop or something and the number of cans that are sold that day at that price. That feels like a reasonable thing that might have a linear relationship to it, right? Uh-oh. What did I do here? Oh, I see. It didn't take my enter. Okay. So I got my data typed in. Everybody else that's following along on their own calculator got this data all typed in. Cool. The next thing we're going to do is we're actually going to look at the scatter plot for this data to make sure that a linear model is actually a reasonable choice. So we want to look at the data and see if it looks like a line, because there's no sense in like using a linear model if it looks like a horseshoe or something, right? Like that would be a terrible choice. So to graph a scatter plot of data on your calculator, we're going to press the second button and then the y equals button. This opens the stat plots menu. I'm just going to use plot 1, so I'm just going to go ahead and press enter to select that. I'm going to start by turning it on, so I'll press enter so that on is highlighted. Now there's a couple of different plots that your calculator can make from data. For this class, we're always going to use this first option, which is the scatter plot, which is just plotting the data as points. Now we need to sit here and think for a second about which piece of our data should be the x-coordinate, which should be the y-coordinate. So if we think back to our Algebra 1 course, we called the x variable the independent variable and the y variable the dependent variable. Does that ring a bell? We say that because typically the y variable depends on the value for the x variable. So let's think about what's going on in this situation. So put on your econ cap here, since we're talking about the price of something and how many are sold. Would we expect price to affect how many things are sold, or how many things are sold to affect the price? I would say the first one, right? That the price affects how many things would be sold. I think that's a reasonable assumption. Everybody agree with that? That seems like Econ 101. I think a lot of us have been in or are currently in an econ class, so that's probably a fairly familiar concept. It's basic like supply and demand kind of thing. So I think that the prices should be our x-coordinate and the number of cans should be our y-coordinate. So on my calculator, L1, which was where I typed in my prices, is already defaulted as my x-coordinate, and L2, where I typed in the number of cans, is already defaulted to my y-coordinate. So I don't really need to do anything. If you did need to change those for whatever reason, notice above the numbers 1, 2, 3, 4, 5, 6, in blue on your calculator is a little L1, L2, L3, L4, L5, L6. So you could type like second and the number 3, and it would replace the L1 with an L3 or whatever. Now, I'm not doing that because I put my data in L1, but if you needed to do that, that's how you can do that. Everybody's okay? And the last option here is how you want the points to show up on your calculator. I like the little boxes because I think the other ones are kind of hard to see. So I like to do the boxes, but that's purely a preference thing. Okay? Now, the next thing we have to worry about is when we go to graph this, are we actually going to be able to see the scatter plot? Because these numbers are kind of weird, right? The easiest way to make sure you can do that is from the zoom. Oops, I guess I'll exit out of there. We'll go into the zoom menu. So you might have to exit out and then go to the zoom menu. And the option we want is going to be called Zoom Stat, which should be easy to remember since we're just in the Stat Plot menu. So we're going to select Zoom Stat, and there is a nice picture of my graph, of my scatter plot. Everybody feel okay with that? Now, if you saw some other lines going on in here, it was probably because you had something in your y equals menu that was kind of drawing at the same time, so you may want to go and clear that out if there's anything in there. To just show you what the stat or that zoom stat did, is it basically reset our window, so our x mins and our x maxes, y mins, y maxes, scales, all that jazz, it reset for us. So what it did is it found it, for the x min, it found a value that was smaller than all the x values in our table, and the x max is an x value that was bigger than all the x's in our table, and the same thing with the y's. Okay with that? So just to be clear what it's doing there, you could do that by hand also if you wanted to, but there's a button that kind of will just do it for you, which that's nice. All right, so let's look at this data. Does it look like a line to you? Looks pretty linear to me, right? Feels like you could draw a line straight through there and everything's pretty close. You guys buy that? Okay, I do too. So let's exit out of here. So what we'll do is we'll build a linear regression model to describe this data, since it looks like a line visually. Everybody's cool? Okay, so to do that, we're going to exit back to the home screen. And this time we're going to press the Stat button. But we're going to move over to the Calculate menu, or the Calc menu. So the Calc menu is where all the regression equations are held. So there's our linreg, quadreg, cubereg, quartreg, another linreg version. I don't know why they needed two versions. I always use the AX plus B one and not the A plus BX one, but like, I don't know. There's a logarithmic one, that's the ln reg, exponential reg, power reg, the logistic one, sign regression, a manual fit option. Anyways, for this course, we're going to be using linreg a lot and some of those other regressions that I listed earlier. A lot of these on here, though, are not going to really be applicable for us. So let's pick linreg. When I do that, it's going to open up this menu, and this menu is going to ask us 4 questions. So it says, well, where is your X data? Well, I typed mine into L1, and the default already is placed L1 there, so I don't really need to change anything. The Y data, well, I typed that into L2, and the default put the L2 there already for me, so I'm not going to change anything. The frequency list, in this course, we're never going to use that option, so just always leave the frequency list blank in this course. If you take a stats course, it may be a frequency list might be important for you, but not for what we're doing. And then the last option is store Reg Eq. So what this option does is it gives you the option to have the calculator take the regression equation that we're about to build and store it somewhere. Now, the obvious place for us that we might want to store this is into the y equals menu, so we can look at the graph of it in comparison to our scatter plot. Everybody okay with that reasoning? So that's what we're going to do here in the store Reg Eq option, is we're going to ask the calculator to store this into either the y1, y2, y3, whatever we want to choose. I'm going to choose to put it in the y1 spot because it's the first spot and it's fine. Now, if you had something in the y1 spot already, when you select this option, the calculator automatically erase whatever's there and replace it with this regression equation. So if you had something there that you wanted to save that you're going to compare this regression equation to, you need to be a little bit mindful of that. But in general, just putting it on y1 will probably be fine. Okay. So we need to retrieve the name y1. So the y's are under the variables button. So if you look below the down arrow, there's the key VARS. That's short for variables. So let's go ahead and press that. And the variable we want is y1. So that's going to be under the y variables tab. So we'll move over to the yvars tab. And our calculator is in function mode for the entirety of this class. So that's the mode we want to press. And then here's the list of y variables. I'm just going to pick y1. So notice that now next to store Reg Eq, I have the y1. And now I'm just going to hit calculate. So let's talk about what this output means. So the calculator says, okay, the equation I made for you is y equals ax plus b. So it's a linear equation. Everybody's cool? It says that the a coefficient in that linear equation is negative 104.6857143. So that's like the slope of my equation. And the b value, the y-intercept, is 329.28574143. And then I got this r and r squared value. How many of you guys, when you typed this in, didn't get that? Yeah, I would guess that most of us, right, didn't get that value. So let's talk about how to make our calculator output that value. So again, the one we care about is the R value, since it's a linear regression. And our R value is negative 9.6 and change. That's pretty darn good, right? The best we could get is -1 or +1, or pretty darn close to -1. So that's a very good correlation value. Okay. For those of you that did this and didn't get the R values to pop up, what we need to do is turn on the diagnostic onto our calculator so that from then on, anytime we run our correlation or any of these regressions, we'll get those R value or R squared values. So the easiest way to get this is to press the second button and then press the 0. That's going to open up the catalog. So the catalog is just a list of every single command that your calculator has in alphabetical order. The command we're looking for is called diagnostic on. So we could scroll all the way down to the D's, yuck. Or if you look at the calculator, the x to the -1 button, above that in green is the letter D. If I press that x to the -1 button, it'll skip all the way down to the D's for me. And then I'll just scroll and find that diagnostic on command. Okay. Once you've found that, press enter and that'll paste that command onto the home screen for you. And if you press enter again, it'll say done. So now if you go and you rerun, so if you press second and enter twice, it'll rerun or give you that linreg command that we just did. If you press enter and rerun it, you'll get the R values to come up when you do your regression. Ava, did that work for you? Okay. Victoria, were you doing that too? What part? Okay, so did you go to the catalog?
No, because I accidentally deleted like a column, so I was trying to figure out how to do that.
Oh, well, I could have told you that.
Yeah, but I got it back.
Okay. Okay. So press second and the 0 button. That opens the catalog. Press the x to the -1 button, which will skip you all the way to the D's. That's on the left-hand side. To the -1 button. It's underneath the math button on the left. Okay, that'll skip you down to the D's. And then just scroll the rest of the way till you find diagnostic on. Okay, when you find it, move your cursor onto it and press enter. That'll paste it onto your home screen. Press enter again. It'll say done. And then if you do the regression, the R's will come up from now on. So you press stat, and then you go over to the calc menu, and you scroll down and pick linreg. You're welcome. So the good part here about the diagnostics, once you've done it once, you don't have to do it again unless your batteries die or your calculator dies or you reset your memory or something like that. But from then on, if anything other than that happens, the R's will stay on, that diagnostic will stay turned on. You don't really have to do that every time you do this. Once should be good from there on. Okay? All right. So let's press, so we saw this was our equation. We looked at the R value. It was very good. So the model seems very appropriate. Let's press the graph button and take a look at our model relative to our line. That looks pretty nice, right? Everybody agree with that? So what can we do with this model? Well, we can use it to make predictions, right? So as a business owner, you might say, okay, well, what if I charged $1.90 for my can of soda pop or whatever these were, soup or something, I don't know. How many would I expect to sell on that day? Right? That seems like a reasonable thing you might ask as an owner, store owner. You know what I mean? So what we can do there is you can plug the number 1.9 in for X into your model and evaluate it to find the Y, which would represent the number of cans sold. Or easier, since we've already done this, is we can do it on the calculator. So if you press second and then the trace button's there up above the up arrow. That's going to open up the calculate menu. From there, we're going to pick the value command, which is the first option. And in place of X, if I want to know about $109 or $1.90 for a can, I'm going to type 190 in for X and press enter. And the calculator says, okay, there's where that point is on the line. You can see the little X there. And it says that the Y coordinate would be 130 and change. So I'd expect to sell about 130 cans when I charged $1.90. Jay? So when you run the regression, we did that store Reg Eq part. So that's why my line came in. So under store Reg Eq, you press the vars button, move over to the Y-vars menu, select the function option, and then select Y1, and then hit calculate to run your regression. And then, Jay, the equation that the calculator makes will store automatically into the Y1 spot for you, so you don't have to type it in manually, which is a huge hassle because there's a lot of decimals on those numbers almost always. Is that okay? Okay, so one type of prediction is called interpolation. And that's what we just did there, where we pick a value that's between the X's in our model So we're just making a prediction about a value that's between the X's in our data set. So like 190 is clearly bigger than the smallest X in our data set and smaller than the biggest X in our data set. Everybody agree with that? The other type of prediction that we can make with one of these regression equations is called extrapolation or extrapolation, depending on how you want to pronounce it. So here we're going to make our prediction about a value outside the X's in our data set. Now, between these two type of predictions, which one do you think is going to be more reliable? Interpolation or extrapolation? Just the gut. Landon? Yeah, interpolation should be the more reliable prediction, because you know that you have data, that's continuing to change with that kind of pattern before and after it, right? Now, if I pick extrapolation and I try to do, say, make a prediction about when the value of the can would be like $3 maybe. Oh. Uh-oh, I got an error when I tried to do that. Why do you think I got an error? So this is purely a calculator reason that I'm getting an error here, not from a mathematics reason. There's no reason I can't plug 3 into that model. The issue is that for me to use the value command, the point that it's going to find has to be on the screen, basically, that the x value that I'm picking has to be something the calculator's actually calculated. If I go and I look at my window, my x max is smaller than 3. So I'm just going to change that to be like 350 or something and just redo it. So I do second and trace. I'll do the value command and pick $3. At $3, it says I should sell 15 cans. Okay, what if I do 350 though? It says I'm going to sell negative 37 cans. Does that make a lick of sense? No, right? You could be like people saying, oh, I'm charging $3.50 a can for pop, and 37 people went and brought me a can of soda and gave it to my store. Like just brought, here you go. Like that makes little to no sense. Like a negative number is really meaningless in this situation. So we can see that extrapolation can give us really kind of awful predictions at times, right? Now, what you'll also find typically is that the closer that extrapolation is to the one end of your data set or the other, it's not so bad, right? If I made a prediction at like $2.55, which is again extrapolation, but it's still reasonably close to the end of my data set, right? We did 250. If I did one for 255, still extrapolation, but that prediction might be reasonable still. Everybody kind of see that? It's when we start getting pretty far from the end of our model that things can get a little bit of haywire, particularly if maybe a linear model is not the most appropriate one. Everybody agree with that? Because at some point on something like this, you'd expect the price to get so high that basically just everybody, just you're going to sell nothing, right? It's just too expensive. So maybe in a real world context, when we think about this, maybe like an exponential model might even be a better choice, since that has a horizontal asymptote that basically it can get to 0 and just stay at 0, which is kind of what we'd expect as the price goes up, is that eventually it just becomes so expensive nobody's going to buy this stupid thing anymore. You know what I mean? So one reason our prediction might be bad is extrapolation. So if you do extrapolation, that could give you a bad prediction. What else might give us a bad prediction? There's two other reasonable things to come up with here based on what we've talked about today. So what if I had used, for my model, what if my data had looked like a horseshoe and I'd used a linear model? Is that going to give me reliable predictions? No. So if we use like the inappropriate model, So if we had, that is, we had a bad R value or R squared value, that's a situation where it's going to be not reliable, the predictions you're making. Does that make sense? And there's one more reason why we might get a lousy model when doing this, or a lousy prediction, excuse me. What's all this built on? Data points. So if you have bad data, you're probably not going to be able to make good predictions from it. When we say bad data, what could that mean? Well, one of the classic is just you have too few measurements to really have any reliability. So if we're doing like, like height versus age, and you just do two people that are like basically the same age, are you going to be able to create a good model out of that? No, right? It just, that's dumb. You couldn't expect something like that to work very well. And the other situation is like you make bad measurements. So we'll do an example here that kind of highlights that. So let me give you an example of bad measurements. So like say you're trying to create a model that's going to predict how tall somebody's going to be with their age, right? Reasonable thing you might want to predict. And you take all your measurements and you do lots of measurements. You got lots and lots of measurements. But everybody that you're measuring is like an adolescent. That's all kind of like, 10 to 16. Is that going to be able to create a good model from that? It's not from too few measurements. The measurements you made were accurate, but what's going on during adolescence with regard to height? You're usually growing a lot, right? Now, are we going to continue growing at that rate as we get older or when we were younger? Probably not, right? That's an example of, again, you made some bad measurement, not because the actual act of measuring you're doing was inaccurate, but you took a biased sample, right? You took all of your measurements from one specific group, and there's like a lurking variable as to why that's not going to be representative for all groups. Does that kind of make sense? So again, in the real world, when you read newspaper articles or some snippet on Facebook or whatever that quotes a statistic or makes a prediction, you really need to ask yourself, okay, that seems unlikely, the prediction that the person's making. Should I believe that or not? What are some reasons that something could have been garbage? And you have to look at things like this. So this is really kind of very practical, common sense, being a good citizen, being able to sniff out some, crapola. You know what I mean? Okay. So let's take a moment here. We're going to look at a specific example. I'm going to just pull number 11 from the homework set. And we're just going to kind of do this one together. So I'm going to give you guys a few minutes to try to repeat this process in your calculator, and then we'll kind of go through it as a group. I'll get up and kind of walk around if you're having calculator issues. But this is number 11 from the problem set here that's up here. If you have your calculator, please take that out and kind of try to work through this after we've just gone through how to use the calculator to do this stuff. If you don't have your calculator with you, find somebody nearby that you can kind of look on, and maybe they'll even let you like hold the calculator and practice the steps after they've done it. That would be really righteous of them and good citizenship and teamwork and all that jazz. Okay? All right. Why don't you guys start on that, and I'll get up and kind of walk around, and if you get stuck on someplace or you need some help or whatever, holler at me. Oh, I was just thinking about this. Are all these people that are gone, are all these people just seniors? Did they just all skip school today? And Jeremy. But Jeremy's Jeremy, right? I was looking, I was like, man, it's a lot of people still. I figured they come in late or something, but.
It's supposed to be senior.
Oh, was it supposed to be senior skip day?
No, he asked me.
Did you miss the memo?
No,
Or you just like, I'm getting absent too much, is it?
No, I came professionally.
And let him know my eyes heavily.
So I was like, this is my time to shine.
I'll be here. Alright, how's it going? Oh.
You like a snack? Sure. Are you in there? Oh, no, not really. I don't know.
He's outside in the hall.
That is not it. Don't mind me, what are they counting?
Yeah, sure. Hi, Landon. Sure. No problem.
What was it? I just like keep forgetting all the steps.
Okay, so exit out of here.
No. Yes.
Oh, really?
Oh, I know, I didn't
Turn. Make sure that's all set up.
No, that's what
Should we
Ah,
So hit that. And then
this teaches this line.
Yep, same stat. Make sure you store it. So cars.
Go back to the graph.
Graph again.
List tree. I like saying
This asks about specific ages or whatever. So you can use the value. Yeah.
Remember.
You don't
this.
love it or like, you don't like it,
No, love it. Okay, so
you're gonna get some credit.
Oh, hang on. So basically, try to look at houses. No. So make sure it goes back. Make sure the windows. Alright. So we have our list. We have the details. Now we need to go to second. Yeah, good. Because your age doesn't go what? So Dixon's age. Not age. He's not age. Whatever one looks for. If you're looking, it's X. Oh, that's the minute one. Hang on, pause. So I know it's true. But like, what did you do? What I do, bro? Is it like some real? I go back to the window. Hang on.
So which is like 7 or something? Yeah, like, no, it's very reasonable.
Now go to windows. Grab this.
Okay, so now you're ready to go right. We need list 3 and list 4.
Something lower than that. What did you do? Oh, now do like the whack and grab, bro. That is whack. What is this? So you hit trace and then enter. How? No. I mean, it's white. I don't think it's no, it's not. No, it's not. It's not like a circle. Like this 94 inches.
I think that's what you should get. Now that's a bonkers thing. It's like a 7-foot person. Yes, I mean, if you look at the ages, like the data you showed.
I see that.
This is exactly the example of like that data.
I just told you I didn't. What do I do?
Probably store your equation.
I can't do it. No, you just spin up even more. We're not doing a table with graphics. Why you have a table? What is that? I can't clear it. I can't clear it. What do I delete? Way to go. You did. Me? Yeah. There you go. Oh, thank you. My masterpiece. What? How do you screw it up, man? Oh, man, I got it. I got it. Hang on. Alright. You got this, right? Cool. You want to?
There's your line. Use that line to answer the question like predict the person's height is 2 years old.
That's so fun.
All we have to do is
Zoom status.
why you commenting on my graphic?
This? That's interesting.
When you think
Are you worried about like this stuff, like vertical?
Yeah.
Well, it's because you have 2 ages and a 10.
We didn't get to take
Sometimes you
long.
can have some vertical and do it so. It's not obvious. If you done like 61 instead of 60.
So he beat you. I'm stuck.
Sure.
Sorry. I would
All right, just to run through this here real quick. So stat, edit. Clear this stuff out of here. Can you guys stop talking, please? Thanks. Oops. So we'll just type in our data, and then we'll type in some more data. Got lots of data to type in. Just as an FYI, when you're typing in this data, you need to make sure that you're being real careful that you have the same number of data points. If you at some, or for some reason you typed in the wrong number of data points, like your L1 has 10 values and your L2 has 11 values or something like that, you're going to get an error when you try to write your stat plot. It'll say like invalid dim or something. So I got my data typed in. My stat plot's already on, I know that. So I'm going to go do my zoom. There's my data, looks pretty linear, or reasonably linear anyways. So exit out of there, stat, calc, linreg, store reg eq, vars, yvars, function, y1, calculate. Our value's pretty okay, 0.94-ish, that's not bad. Here's my best fit line coming through. Now, if I did the zoom stat and then I try to do the value at 20, which is what the question's asking about, predicting someone's height when they're 20 years old, gives me an invalid because my window isn't wide enough to get to 20. So all I'm going to do here is I'm just going to go change my X max to be something bigger than 20, I don't know, like 22 or something, and then just redo that. Or the other option, I guess I should have said this at the first point. So, oops, I did 22 and not 20. Anyways, but you get the idea, right? The other option that we can do is from this screen, and if you do it this way, you don't have to worry about the window. This is why I'm bothering to mention this. So the other way I can do this is basically when I do that value of 20, what I'm doing is having the calculator plug 20 in for X into that Y1 spot. Is I can tell the calculator to do this from the home screen here, and then the window part doesn't matter. So I'm going to pick vars, go over to the Y vars, pick function, pick Y1 because that's where I stored my equation into. And then like function notation, I'm going to do Y1 of 20. Like it was a function notation or something, right? And I'll spit that out. And now the window doesn't matter if you want to do it that way, which might be nice after you've looked at the graph and gone, okay, everything seems in order. This is linear. The best fit line looks nice. And then if I have to do some predictions, maybe doing it from the home screen might be a little bit easier because you're not limited by the window in any way. Maybe I should have mentioned that the first go around. But that's a nice option also. Does everybody feel cool? No big deal? Okay. We'll stop here for today so that at this point you guys should be able to do 5 through 12. On Wednesday, we meet again. We'll talk about the rest of the regression models because at this point it's just like the same steps on your calculator. The only thing that's going to be different is like picking the different regression model. But everything else we're going to be doing is like exactly the same, technical. So that's really nice, right? But we'll deal with that all on Wednesday. Okie dokie.